Okay, everybody. Today I am going to show you a couple quick more examples here that I did not include in the first video, but I definitely need to. So if you look at this first one here, we have 3 times the square root of 49. And so if you look at this problem, this has an extra 3 out here that we did not have in any of the previous problems that I showed in the video. So I wanted to show you how to deal with a number out there. So what you see here is we only want to really worry about the square root for right now. That's the square root of 49. The square root of 49 actually becomes 7, and that 7 then simply multiplies the 3 to give you 21. And that's it. That's how that problem is done. Show you one or two more like that. Here's 7 times the square root of 125. Now 125 can be broken up into 25 times 5. And then each of those numbers will be square rooted. 25, of course, is a perfect square. 5 is not. So you'll have 7 times the square root of 25 times the square root of 5. Now this right here will turn into 5. But the square root of 5 will remain there. And lastly, you'll multiply 7 times 5, which will give you 35 square root of 5. And there's your final answer. Now, I also want to show you an example where you might have more than one number on the outside of the square root. So in this case, we have 2 square root of 3 times 4 square root of 2. And so what you can do is you actually can rearrange this a little bit because it's all multiplication, and multiplication is commutative. You can actually rewrite this so it's 2 times 4 times the square root of 3 times the square root of 2, like that. Now, because both of those numbers under the square root are being square rooted, you can rewrite that as a single multiplication problem as well. So like this, 3 times 2. Now, what you have to double check is that 3 times 2 does not create a number that's a perfect square, because if it would, then you would factor that out as well. Or not factor, but you would square root it, bring it outside of the radical. But in this case, the square root of 6 is not reducible. So this turns into 8 times the square root of 6. And then there's our final answer. So one more I want to show you. Same type of deal here. We have 2 numbers that are underneath the root, but this one's slightly different than the last one, and you'll see here in a second. So when I reorder this, we are going to reorder this as 3 times 2 times the square root of 4 times the square root of 4. Now, because both of those numbers under the square root, they're both under square root, they can be multiplied. So you can only multiply pairs of numbers that are in the same location. So you see the 3 and the 2 are outside, so we'll multiply those together. And then the 4 and the 4 are also outside, so we'll multiply those together. But they'll remain underneath the square root. So what we get here is we get 3 times 2, which is 6. And then we get the square root of 16. Now, the square root of 16 is a perfect square, so that will simplify down into 4. So it gives us 6 times 4, which is 24. And there's our final answer. So thanks for watching this second video. I did want to include these in the first video, but I didn't have a chance to. So if you have any questions, as always, feel free to email me. Have a great day.